In this video, I'm going to show you how to configure Network Time Protocol, or NTP. So the purpose of NTP is to provide time synchronization between all network devices. So it is a management protocol, and it's hierarchical in nature. That means you have different levels or stratums. So the internet has a stratum 0, that's connected to an atomic clock, and that's the most accurate. So that stratum 0 provides the top level time source. Then you'll have a stratum 1 device within a private network that'll connect to that stratum 0 for time synchronization. Then that stratum 1 device, a Cisco router for example, or a server, is then the time source for the internal devices. They would be stratum 2. Since this is packet trace, so what I've got is an NTP server, this is going to model the public time source that will be distributed to these routers and provide time synchronization. Go to this NTP server here. So it's just basically NTP is on. What I want to do is enable authentication. So I'll use the number 35 for key, and password is CISCONET. So I'm going to configure the same authentication key on R1, R2. That provides encryption for the NTP messages between the devices and the server. That key and that password will provide an MD5 hash for the NTP messages between the Cisco devices and the NTP server. So that provides authentication security for the messages. We'll start the configuration on R1. First command is NTP server 192.168.3.1. This is a global command. This tells R1 what the IP address is of the NTP server for network communication. This next command is for authentication security. So NTP authentication key 35, that's going to match what's on the NTP server, and enables MD5 hashing. The MD5 is the hashing algorithm. That's going to be used on the messages, and CISCONET is password. And then NTP trusted key 35. Maybe a hyphen between trusted key there. And then NTP authenticate, that will enable the authentication. Next command, you want to configure the local time zone. It's a space there. So that's enabled now for NTP. Now I want to go to R2 and do the same commands. So the first command again is NTP server 192.168.3.1. And the same authentication key 35, and CISCONET must match with the NTP server. And NTP trusted key 35, then NTP authenticate. I'll just do a copy run to start. Now I want to verify NTP is working. Command to show NTP status. What I've got here, clock is synchronized, stratum 2, reference is 192.168.3.1. So that's on R1. Here, the clock is synchronized, stratum 2, and the reference is 192.168.3.1. Back to R1, and the reference is 192.168.3.1. Shows you the pole interval is 5, and last update was 8 seconds ago. NTP is hierarchical, so that means that if this is stratum 2, this NTP server is configured as stratum 1. So if I configured switch 1 with NTP, and I pointed the NTP server IP address to R1, then switch 1 becomes stratum 3, because it's deriving its clock from R1. That's how that works. The other thing you can do with NTP with packet tracer and NGNS3 is configure NTP master command on the device, and then that acts as the local source. That actually then simulates the public internet NTP server. So that's something you can do as well if you want to configure the NTP server right on the Cisco device. That verifies NTP is operational. That concludes the video.